Okay, pre-calc, our last video in our unit about limits and derivatives, and we're going to talk about instantaneous velocity. So those of us who have taken physics this year or last year, you would have seen probably a lot of these types of problems. It has to do with an object that is falling or rising for that matter, and the velocity at any given point. Now when we talk about velocity, really we're talking about slope, the time it takes to travel from one point to another. And we're going to use instantaneous velocity to find it at one point. So it's a lot like we talked about with our tangent line. As our 2 points get infinitely close, what is the velocity between those two? Okay, so we're going to use our same formula there. We're doing the derivative still. F prime of x equals the limit, our definition of our derivative still. Okay, so we're doing the same exact stuff, except for we're going to change it a little bit. So here we have s of t, which is the same thing as saying f of x. And this is going to be our height. Okay, so we have a ball thrown with a height based on the given equation after t seconds. So t is our time, s is our height. This negative 16 has to do with the acceleration due to gravity, so we're going to be talking about in feet. Our height is based in feet, we should say, and our time is in seconds. This 80 is going to be our initial velocity, or our initial value. And 96 is going to be our initial height. Okay, so since we're throwing it off a roof, the roof is going to be 96 feet high, and our initial velocity would be 80 feet per second. So when we talk about velocity in this problem, it's going to be in feet per second because those are our units. Height's going to be in feet, and then our time will be in t. Okay, so we're going to need this. Now, a lot of these other parts of this problem are also going to require our first derivative. Okay, and so we need to figure out our first derivative. Same idea, the limit as h approaches 0, and we have to make just a few clerical changes because we're talking about s and t instead of f and x, and so it's going to be s, and instead of x we have t plus h, not minus, minus s of t all over still h. And if we plugged in and simplified, okay, it wouldn't be the prettiest thing in the world, but we should, in the end, get negative 32t plus 80. So if at any point you are being asked to find the instantaneous velocity, we're going to need to use this equation. Okay, so this is going to give us instantaneous velocity after time t. This is going to give us height after time t. So we're going to need to make sure we choose one of these two equations depending on what we are given or what we're being asked for. Okay, the first one, when does the ball land on the ground? So if we are being asked when, we need to find time, and landing on the ground tells us that our height is 0. So in order to do that, we're looking for time again, but since we're talking about height, we need to say our height, which means this equation. And since we land on the ground, we now have a height of 0 feet. And if we do our quadratic formula, we would get two values for t. T equals negative 1 and t equals 6. Negative 1 doesn't work because that would be talking about in the past. So in this case, the ball is going to land on the ground after 6 seconds. Okay, and again, I just said that my height had to be equal to 0, and then I did the quadratic formula to solve for that. Okay, at what time t will the ball pass the rooftop on its way down? So again, we're finding t, and it's passing the rooftop on its way down, which means we're talking about height again. So I'm going to set up an equation, and because we're passing the rooftop on the way down, this has to be negative 6. Okay, another thing to keep in mind, that since we're going down, our speed is going to be negative. Now, we're not really worried about that at this point because we're not asking for the velocity. We're asking for the time. If it took us 6 seconds to get all the way to the ground, I know that my time is going to have to be less than 6 seconds if I did this correctly. So if I solve this, I'd subtract 96 from both sides, and I'd end up with that. And again, if I solve this equation using the quadratic formula, I'm going to get t equals 0 and t equals 5, which makes sense because at 0 seconds we were on the roof about to start, so we should have been at 96 feet, but we don't want that one. On the way down, it would have taken 5 seconds. Okay, the next thing, what is the average speed of the ball? So if we're talking about average speed, in this case we're finding slope. So what I need to do is find s of 0 by plugging in 0, and if I did that I would get 96, and t sub 2, I'm finding s of 2 and plugging that in, I'm going to get 192. So I need to take my feet, 192 minus 96, over my change in time, 2 minus 0, and I would end up with 48, 96 over 2, and so since its average speed, that is 48 feet per second. A big thing in this one was that I just did my slope, my change in y, which is how I got these two, over my change in x. Okay, instantaneous speed of the ball. So instantaneous speed of the ball is now when we are talking about our first derivative. So we're looking for s of t at time sub 0, which means time is 0. So really what I'm looking for here is s of 0, and like I said at the beginning, if we plugged in s of 0 into, remember this is negative 32t plus 80, if I plug that in I just get 80 feet per second, which makes sense because way back in the beginning of the problem we said our initial velocity was that number in front of t, which was 80, and so our initial velocity is the same thing as our instantaneous speed at 0, 80 feet per second. Okay, we've got 3 more parts to this problem we're going to look at. So what is the instantaneous speed of the ball at t equals 2? So instantaneous speed of the ball tells us we're looking for s prime, and at t equals 2 we're looking for the time at 2 seconds. Meaning I am just plugging in negative 32, t now becomes 2 plus 80, and if I plug that in and simplify I get 16 feet per second. Okay, so as long as you find your derivative and understand what you're being asked for, it's really not too complicated. It's a lot of just plug and chug. Okay, and the next part, when is the instantaneous speed of the ball equal to 0? So think about the ball's flight path here. It's going to go up and it's going to be half speed at that point, and then it's going to turn around and come down until we hit the ground. So here our speed would be negative, here our speed would be positive because it's going up, which means our speed is 0 right here at the vertex. Okay, so when is the instantaneous speed? Again, we're looking for when, and we're talking about instantaneous speed, which means we need to find t when our instantaneous speed actually equals 0. So we need to use that equation. Solving for t, subtracting 80, dividing by negative 32, we would end up with 2.5 seconds, which means it takes 2.5 seconds to get here to the top where it kind of has 0 motion, pauses midair for a second, and then we come down negative. Okay, and then the last 2 parts, when is instantaneous speed of the ball as it passes the rooftop on the way down? So what is the instantaneous speed? Means we are looking for s prime, and as it passes the rooftop on the way down, this is one where I mentioned earlier, it needs to be negative. Our speed has to be negative here because we're coming down, and we have to remember that piece. We found that after 5 seconds is when we pass the rooftop. So really we're looking for s prime of 5, which means negative 32 times 5 plus 80, and if I simplify that, negative 32 times 5 plus 80 is going to give us a negative 80 feet per second, which makes sense because we're coming down and should be negative. Okay, last one then, when is the instantaneous speed of the ball when it hits the ground? Again, going back to that first piece, we found that it hit the ground after 6 seconds. So we are trying to find s prime of 6, which means we're going to do negative 32 times 6 plus 80, and we get negative 112 feet per second. And that would be the instantaneous speed. So there's really a lot going into these problems, quite a few pieces. It's really just a lot of algebra as long as you can find the derivative and kind of break through into pieces on what you are being asked to find and identify which equation we're going to need to use because of that. We won't have any problems. So instantaneous velocity, we have to find the first derivative, and then we're going to have a lot of applications with that.